Hi, everyone. Thank you so much for attending the Port St. Lucie Utility Systems Lunch and Learn. I'm seeing some familiar faces. Thank you so much for coming back and learning more about this awesome department here in the city of Port St. Lucie. My name is Jenny Tomes. I'm the Assistant Manager of Utility Community Outreach. So this is the third installment of our Lunch and Learn series. We have an amazing panel of experts with us here today. These are folks from our water treatment plant and water distribution divisions. So they're going to be sharing with you all about where our water comes from, how we treat it, how we keep it safe, how we get it to your house. So when you turn the faucet on, there's no question that water is safe and up to the high standards that we have to meet. So before we get started, I'd like to introduce our event sponsor. This is Tiffany Velez from South State Bank. She's going to talk to you a little bit about their services that they offer.
Thank you, everyone, for showing up today. I see a lot of familiar faces in the audience. I am Tiffany. I'm a relationship banker from South State Bank, located on the corner of Lingate and US 1, directly across from the Port St. Lucie Hospital. I have a ton of product information in the back there. When the event's over, I'll be more than happy to answer any questions. Enjoy the event.
All right, so as I mentioned, so some of you were here last time, we talked about sewer, which is not always the best thing to talk about at lunch, but today we're going to be talking about the clean side of what we do. We're going to be talking about the water treatment and distribution side. So I'd love to introduce our panelists to you. Right here we have Bilmer Serrano. He's the lead operator of the James E. Anderson water treatment plant. Next to him is Mark Paisano. He's the lead cross-connection tech. Next to him, David Reyes, supervisor of the Water Installation and Preventative Maintenance Division. And on the end there, we have Robert Grasso, who is the lead in the Water Distribution Division. All right, so real quick, just to kind of break things down, our water by the number. So we have over 88,000 water customers, and every month that number goes up and up and up. There's so much construction here. There's so many people coming here, moving here. So we're up over 88,000 customers now. We have 47 Floridan and surficial wells throughout the city of Port St. Lucie. We have 3 water treatment plants that have the capacity to produce and treat over 41 million gallons of water per day. We also have the storage capacity. We have 10 water storage tanks throughout the city. Those storage tanks can hold over 26 million gallons of water. We have over 1,200 miles of water main. So we love to talk about this. So if you were to unearth all of that water main and lay it end to end, it would travel from Port St. Lucie all the way to Indianapolis, Indiana. So just to give you an idea of how far 1,200 miles is. And then we have almost 6,000 fire hydrants that have to be maintained, have to be flushed, have to be maintenance. So that's a tremendous responsibility. That's a tremendous amount of infrastructure that we have to make sure is working properly. So when you all came in, gave you a little quiz, and it's no big deal if you don't know the answer, but does anybody know where our drinking water comes from? Yes? B, Floridan Aquifer. Who says B? Who says Floridan Aquifer? Good job. Yeah, you nailed it. Comes from deep, deep, deep underground. So I'm going to let Bilmer talk about how we get that water up out of the ground and then how we treat it.
Thank you, Jenny. Like Jenny was saying, my name is Bilmer Serrano. I'm the lead operator at one of the 3 water treatment facilities for the city of Port St. Lucie. I've been there almost 20 years this year. So to get into the process, like Jenny was saying, with the wells are basically our lifeline for our water production and water treatment. Like she was referencing, and you all got right with the source, it's from the Floridan Aquifer. Basically, there are 3 general aquifers in the state of Florida. The southern one that starts right around the Palm Beach County line south is the Biscayne Aquifer. And from Palm Beach County up to us to about Cape Canaveral west is the Floridan Aquifer. That is where we get our water from about a range of 1,300 to 1,800 feet below the ground. Those wells are pumped using 100 horsepower motors. And did we want to go through the slides? Okay. So right now we're looking at the, am I okay to stand up with the, okay. Just so I can see better. So this is basically the layout of one of our Floridan aquifer RO wells. This one here is the one that's basically on site there at the facility. And generally when you build a water plant, you want to use that site there to do your pilot testing or your pilot study. So I remember in my early days with the city, we were going out here and it was basically just cows and pasture out there, and I would have to go through the muck and move alligators aside to get to this well, and we had to test it when it was basically in its pilot study stages. But like I said, we have the RO wells that supply the plant, and from here, that well feeds and goes into the plant, and they're on site, and we can go over to the next process. This is all of the stainless that you see there is a micron canister. That there that Jenny's holding up is a micron filter. So this is the pre-treatment process within the within the system. And that RO water from that well gets pushed through that micron there. So the RO water from the well goes through that micron. And the purpose of that micron is that it removes all of the larger particulates, your sands and silts, before it goes deeper into the system. After there, it gets pushed into the high pressure pumps. And the system is basically moving through motors and pumps just to keep the water going through the process. From the feed micron, it goes into the high pressure pump there on the left, and then it gets pushed through the vessels. The vessels hold the membranes that you see here in front of you. This is basically there you go. These are basically the meat and muscle of the RO process. If you, to give you a better understanding of how it's set up is, if you took a phone book and you were actually able to manage to roll that phone book up and wrap it, that's basically how the membranes are set up. The water, it's a little hard to tell, but the high pressure pump raises the pressure from about 50 to 60 psi up to about 250 psi. Through the ends here, nothing happens here. This is just for the integrity of the membrane. So all of the quote-unquote magic happens on the inside. And what it does is the general nomenclature throughout the industry they're called membrane filters, but technically they're not a filter. This is a filter because all of the water that's pushed through it goes through it. The water that's presented to the membrane at the beginning of it, it gets pushed through, but it's more of a water separator because you can only apply so much pressure before it exceeds its maximum capability. So after it goes through or we can go to the next slide there. So osmosis, if you've ever heard that word, osmosis happens in nature just basically naturally. That's direct osmosis. You could really say that it's natural osmosis. The thing about water is it's always wanting to neutralize itself, stabilize itself. So in nature, it always wants to go, if you had just picture the water, if it was really dirty on the left side and not so dirty on the right, it's always trying to neutralize itself to even itself out. What we do is we flip that system, and that's why it's literally called reverse osmosis, so that we take, I guess you could say, untreated water and push it through the membrane, that membrane there. to get a cleaner drinking water. After that, the one thing we always say in the industry about membranes is the good thing about reverse osmosis is it makes really good water. The bad thing about reverse osmosis is it makes really good water. And I mean that by the water after the membrane is a very aggressive water. So after the membranes, it requires a whole nother system, and that's the stabilization or the the degasification. But this picture here is basically, that's how we got this membrane. The reason we're able to get this membrane here is, this is actually from the plant. We are in the process of changing all the membranes out. The white vessels or tubes that you see, those don't change. Those just hold the membranes. Industry norms, these membranes are made to last anywhere from about 7 to 12 years. I don't know if I actually put this one in, but I've been with the city for, like I said, almost 20 years, and that's how long we've had these membranes. So from a performance standard, you can say we've done a really good job, that we've made them last way longer than what they normally do. And you can see that that's the change out being done, or what have you there. So like I said, the water is very aggressive after the membranes do their job. And the stabilization is from these towers here. So basically, after the water goes through the membranes, it gets pushed up the pipes, and then it falls down the big white towers that you see. The pros and cons, or other pros and cons from membranes is they remove all physical matter, all the really very small attributes that micron filters cannot remove. This is basically your sands and silts. This is all the particulates at the micron level, what these remove. The one con with membranes is they can't remove gases. So like I said, that the water is aggressive after it goes to the membranes. Another issue is we have to remove the hydrogen sulfide, H2S, or if you've ever dealt with raw water, or what's it called? Well water at home, basically the rotten egg smell. So to address that, the water goes up the pipes. Down on the bottom, there's really big blowers or fans that introduce air to the bottom, all the way up to meet the cascading water that's falling down. Like I said, if you've ever dealt with well water at a home, if it's not so bad, you can take a spoon, dip it in the water, and really stir it up, and it'll dissipate that gas. We're doing that here, but on a humongous scale. After the water falls through the towers, it goes into a big basin, and it's basically a big box, and it allows the water to be disinfected. And it goes through that process. It moves really slow because that's the best way for disinfection to do its job. And again, the water is still in its aggressive state, and that requires the stabilization process on the backside. So on the overview of this is basically you can see that tank where the water's going through it, and it just looks like a really big maze where the water goes back and forth. And after that, those blue pipes you see are the pumps that pump the water from the basin over to our ground storage tanks. Like Jenny was saying, that we have those ground storage tanks throughout the city to be sure if anything arises, any emergencies, we have the reserve of water to be able to have that pressure and that demand, or to be able to meet the pressure and the demand. This is a really good picture because it shows a few different systems. So you can see the water, or the flow is on the right side, that aqua-colored line. That the water comes up that line, cascades down this tower, and the air is introduced from the bottom, and it shoots up and you can see it follows the flow. That rotten egg smell is basically just dissipated into the air. Back a long time ago, when a reverse osmosis, or the process of reverse osmosis was new, you could just release that rotten egg smell out to the atmosphere. Well, DEP and all the regulating agencies have tightened the reins on us in the past few decades. You just can't do that anymore. These other sets of white towers here are meant to scrub basically that rotten egg smell from a gaseous form into a physical one. So it does the process, and it turns it into basically a sludge, a light sludge, and we send it to the wastewater plant. So that's what we have to do with the rotten egg smell that thieves do not remove. We have to scrub the air out and then send it to the wastewater plant. So the blue pumps that we were just showing on the basin pump the water from the disinfectant over to the ground storage tanks. They're strategically located throughout the city to maintain proper pressure and meet the demands of the day. And then from there, the high service pumps are set to pull the water from the ground storage tank and basically send it out into the distribution system.
We have to dive into that 1,200 miles worth of distribution systems. Clearly we could talk water all day, right? Can you tell how much we love it? Can you tell, right? Like, we love it, right? Like, this is a lifestyle. But I wanted to ask you quickly, because this question comes up a lot. So if I were to give you the Pepsi challenge right now, if I were to give you some of our tap water and bottled water, could you tell the difference in the taste, maybe the smell? A lot of people can tell the difference, right? So I would argue that even bottled waters taste different from brand to brand to brand. Some of them taste very plastic, right? Some of them actually taste like the bottle that they're in. But it depends on the source, right? So it depends on where the water's coming from. But I have some examples up here. I have Aquafina, Dasani, Nestle, Pure Life, Members Mark. So next time you buy a bottle of water, if you buy them, just look on the label. So you obviously can't see it, it's so small, but this is purified by reverse osmosis. Well, now you all are reverse osmosis experts, aren't you? Because Bilmer just explained it. So they treat their water the exact same way that we do. So what's the difference? Why do these taste different than our tap water that we've actually provided for you here today? That is straight from the plant. Why do they taste different? $2? Yeah. Yes. Purified water. So it just means that minerals are added back in, right? Because Bilmer was talking about how we actually strip everything out because we almost treat it too good, right? So we take everything out, we have to add some of that raw water back in. That's exactly what these bottle companies do. But here's the difference between us and them. These answer to the FDA, the Food and Drug Administration. They don't have 1,200 miles of distribution system to send this water to, right? They treat it, it goes in a bottle. Ours has to go through that whole system. We have to answer to the Environmental Protection Agency, the Florida Department of Environmental Protection. We have these very high standards and regulations that we have to consistently meet. So the water that leaves the plant has to be just as safe at the end, the last house, the last cul-de-sac in Port St. Lucie, that water still has to measure up to those high standards. So as you can see, we defend our water, we drink our water. Every one of these guys up here tapped into our tap water, so hopefully you taste it too. But do you have a better appreciation now of where your water comes from? You just turned the faucet on, right? Do you ever consider that it came from 1,200 miles? The distribution system, but it also comes from deep, deep, deep underground. So next time you turn the faucet on, please remember us. Please remember everything that water has to go through. So again, we're all experts now. We know how we treat our water, right? What's the process we use? You got it, reverse osmosis. So I'm going to pass this over to Mark Paisano, who is going to talk about just the importance of making sure that distribution system is still working, that our fire hydrants are working properly. So I'm going to let Mark take over.
How you doing, everybody? My name is Mark. I'm with the Cross Connection Department. We basically, every day we go out and we flush hydrants throughout the system to make sure the quality of the water is good. I mean, Bilmer takes care of it from the plant aspect, but obviously when you get to the fire hydrant, things change, So throughout the system. Sometimes there's people that go on vacation, there's snowbirds or whatever it is. Maybe not as much water is being used in certain areas throughout the city. So we go through the whole city and we flush hydrants in all the areas around. You may have seen some of our guys out there operating hydrants. Like I said, they're out there all the time. We also have what they're called automatic auto flushers out there throughout the city. We probably have maybe, I'm going to say, maybe 80 of them around the city, and they're all on timers with signs on them, and they go off for, let's say, maybe 5 hours a day, typically during the evening hours when everyone's sleeping, to help maintain the water in the system, because we can't be everywhere throughout this, because there's just like she said, there's so many miles of water main out there. We can't be at every hydrant every day. So that helps us maintain the system. I mean, this gentleman over here, he was talking about sediment inside his water heater, and that, because we go out and flush these hydrants, that supposedly helps that as well. Also, there's a lot of building going on, so you have a lot of different contractors that are out there. Maybe they don't know particular what they're doing, or there are people are out there learning, and they may cause problems out there in the field. They may get a little dirt in the line, so we come out, we flush the hydrants, we run tests, we test the water to make sure everything's good. Also, in the cross-connection department, we have what they call is backflow prevention. We have them typically, you'll see them in commercial settings. They would be outside by the water meter. These devices, we go out and we test them every year to make sure they're working properly. Some would be found at residential. You'll see these if they're using city water for irrigation. You'll find these devices on there as well, these backflow preventers, and it helps prevent any water that may get into the system from maybe like an irrigation pipe or whatever. So it would help, basically help protect your neighbor that's next to you, keep it isolated at their home. Basically that's pretty much it. We do other things as well. We do water meter testing. We go out, we test the residential water meters. We do cross-connection inspections. Some people out there in the, I'm going to say in HOA, if you're living in HOA, like maybe Veranda Gardens or Ballantrae or whatever it is, they have what they call is reclaimed water. And we also go out and do inspections there. We go there once a year. Sometimes we do pop-up inspections there as well. What we do is we would go to every resident and we would turn the water off to ensure that there's no cross-connection between the reclaimed water and the city water, basically to protect you and also to protect us. Basically, that's pretty much in a nutshell what we do.
Right, yes. Now over to distribution and installs and preventative maintenance.
Good afternoon, everybody. How you guys doing? My name is David Reyes, and I am been here about 22 years so far. And I'm in charge of the water installation department / water maintenance department. And just to touch base on the theme, which is to, when you turn the tap on, you want water to be there. Without it, we'd all be in trouble. So let's just take a quick look at, we're going to take a look at some pictures. We also have some visuals right here, right in front of me. And just to show you guys just kind of what that looks like, what it takes from the treatment process of it, and then also getting that to the consumer, you guys, whether it's commercial, whether it's residential, and just show you a little bit about what that looks like. So right here on your left, that's just a standard double service box. You got 2 meters, one being for one resident on one side, and then the other. You guys have probably seen this in your own homes at some point, or thought about it, or heard about it. So that's just what it looks like inside the meter box. We have our U branch there, our angle valves, which turn the water on and off. Your 2 meters, and we also another added protection is you have those 2 check valves. They're right up by the PVC pipes there that look like they can unscrew. Those are the check valves, so that just prevents water coming back from your home into our system. The picture on the right, that's a water conversion. We split it up into two basically categories for water installations, which would be conversion, which would be a homeowner like yourselves wanting to go from well water and connect to city water. And then new construction, we'll show a couple pictures of that as well, but they're all basically the same. Right here, that's just our trench. You know, we got to connect from our meters over to the home, and you can see up there, that's the old well system that they have with the softeners and the pump and all that stuff is over there. So we would basically disconnect the service from the well and connect our service. And I think there's another slide that kind of shows. All right, so right here we have a couple examples. So once we make that connection from the water meter, trench, lay our lines, and then we connect over to the house. You can see it here on the left-hand side. We have a shut-off valve and a hose bib that we provide the customer with. There's another example of it over here on the right-hand side. And that's what a water conversion looks like. It's just getting the water from our water mains, and that's how we make that connection so that you guys can have good, clean water at the taps. We also have visuals here. That's a water main there and, real live action. But we also have, so you can just take a quick look if you guys want to get up afterwards. We do have some visuals over here of the water main, what it looks like. They vary in many different sizes from 2-inch all the way up to even 24 and even bigger. But on average, what you're going to find up and down the roads is like 6-inch main. So right here on the left-hand side, that is our water main. Looks like about a 6-inch main, and that's a tap saddle, which you'll see you have that blue piece there. That's our tap saddle. The band holds everything together. And then that's our corporation, the brass part of it. So that's where we would make our connection using a tapping tool. I'm sorry, I don't have a visual of that, but that's how we would make our connection, and that also serves as a shut-off point if we needed to. What looks like to be like a groove or a line there, that's where we would shut it off at if we needed to. And also when we make our connection, we can shut it off, complete the job, and then turn it back on. So going from that tap saddle over here to the right-hand side of the picture here, right down at the bottom of the picture, that's where that saddle is. So then by way of that 1-inch black poly service line, that is what leads to our angle valve that you've seen in a previous picture with the 2 meters. So that's how we provide water service to all our residents. They vary. Some services do vary in materials and parts and things like that, but just basically as a whole, that's what it's going to be. We connect from our water main by way of a service line, whether that be poly, which you see here, which is just a flexible poly line, or it could be other materials such as brass, even PVC pipe in some cases, which is usually older. We usually don't use that anymore. Like I said, in the previous picture, that poly would lead up. Go ahead and back to the first one. That poly would connect directly to those angle valves right there, right underneath the dirt. You can't see it, but that's where that connection is made. Goes to the meters, to the check valves, to the service line, or the homeowner, what we call a house line in most cases, which then connects to the home. On a conversion, we would do everything from start to finish. So if some of you guys are on well water and you wanted to convert, we would get to the job and we would do it from start to finish, from the road, from our water main over to the house. In a new construction setting, we do everything except for connect to the house because it's under construction, and obviously that's all permitted by the builder, and they have their contractors that would come out and make that connection from our meter over to the house. They would take care of the rest. We've got some maintenance situations here. I'm sure you guys have seen stuff like this probably just riding around in the city. And this particular one is hit by a contractor. I believe they hit the water main on this one. So yeah, This is just the other side of it, the maintenance side of it, which unfortunately, things like this, they happen. We can't really prevent them. As these guys were talking about, we have a lot of contractors throughout the city that are doing, they're doing their work. They're laying their utilities in the ground. They also have a job to do, and unfortunately, things like this do happen. So when something like this happens, we're called out, and we have to make that repair. Not live like this, but we do have to shut the water off. Which before we did that, we would contact the customers, knock on the doors by this service interruption door hanger here that we have. We do hand it out. We are. Well, we have to do it. It's just a standard, DEP regulation that we have to notify the customers in case they do have to boil the water. It's just a notice that we have to hand out. So once all that is done, we do have to make repairs, and I think there are some pictures of some repairs. This is actually the repair that we made on the one that you've seen previous, where the water was bubbling up. This is that repair. So once we make the repair, we turn the water back on, and that's part of some of the flushing that you might see throughout the city with a sign. This also is included in there, not just auto flushers just to maintain the water, but in a situation like this, we do have to flush, whether it be from a fire hydrant like this that you see with a sign on it just explaining what's going on and contact information, or it could be from a hose bib at the meter. But flushing is mandatory, as well as back T samples. So 2 days consecutive of clean samples, just so the water that you're drinking is safe, and also for us as well. All right, so yeah, also part of the water installations, sometimes we find ourselves having to install a water main in certain areas. And right now, currently, we are installing water. This is Southwest Becker Road. You guys familiar with Becker Road, I would imagine? So it's like the very, very south of Port St. Lucie almost. So in this situation, I think it was zoned earlier in the past, or later in the past, that it was zoned for commercial. So some of these areas, some of these certain blocks did not have water. So now they're starting to build residentially. So we have to supply water. There's no way around it. So this is just kind of what it looks like, some of our connections that we've made by tapping into existing mains, making all our connections, going down the block, and also this situation would call for also more flushing, more testing. So not only in lines that we're installing, but existing lines, they all have to be safe for drinking purposes, obviously, for the consumer. All right, and we come across this one monthly for sure. We usually have somebody that just either didn't see the hydrant or went off the road or something, and this is a hit hydrant is what it is. And you can see the building in the back. You're probably familiar with where that is. That's right over here. So the hydrant was hit, and in this situation, the water's not leaking. The good thing about fire hydrants are if they're hitting the right place, right above here, they are made to just topple over and not cause any leaks if they're working properly. There is a coupling inside of here just underneath this flange. This flange will break away. There's a coupling in there that's made to just split in half, like shear off, so that this valve at the bottom will still maintain water pressure being pushed up. Yeah, you can turn it to the side. There you go. So this valve right here, if everything snaps off clean here, the water pressure will still be maintained here, maintaining that seal so that you won't have any leaks. So that's a perfect example of what happened here. Unfortunately, the hydrant was hit and, damage did occur, but we were able to go out there, reinstall the hydrant, and you probably wouldn't know it when you drive by there today. All right, and I believe this one here was the lightning strike. Okay, so this one right here, it does happen. Unfortunately, we live in Florida. Thunderstorms are inevitable. So somehow this one got hit by lightning a little bit after hours. And the same process goes for most of these leaks. We have to notify the residents that the water is going to be shut off. We have to shut the water off. We have to make the repairs. They all basically kind of look the same. I think one of the biggest challenges of this is just, what's it going to look like when you get there? What are the conditions? You may run into other utilities that you have to avoid and work around. So it can be very challenging at times, for sure. Some repairs are simple and some repairs are very very lengthy. We actually had one last night that was very crazy. Didn't go home till 3 a.m. But these things happen, and we can't just go home and go to sleep. But we have to make the repairs, because when that particular neighborhood, this was late, but when they wake up in the morning, like I said earlier, like these guys have said, they want to wake up, they want to turn the faucet on, shower. They want to, make coffee, and they want to shower. So if that's not available, then that's a problem. So that's why we have to stay out there and do what we got to do to provide that for the residents. Okay, and this is another one. This was recent. This was last week, I believe. We're not sure on this one if the hydrant was hit or if it just snapped off, which I've never seen before in my 22 years. But on the left, the hydrant, we held it up like that. The officers had to come and give us a case number, basically, and snap some pictures. But what we had to do in this case is we had to just replace the entire hydrant. Yeah, for sure. And in certain situations, in certain leaks, and we do not have to shut the water off and affect any customers. So that when we don't have to shut the water off and affect, even better for us, better for you guys, that we don't have to interrupt service and boil water notices and things like that. So that was one of the easier ones. And in this case here, with the valve in the middle, that valve was leaking. It did involve a shutdown, unfortunately. We went through the process of boil water notices being handed out to the residents. This is the final repair here. On the right-hand side, we did replace the valve. And you can see what we had to do there. We had to make the connection with the valve, and then it's just like a coupling. You got to put two pipes together. There's different materials of doing that. This one being one of the easier ones, very quick, just 2 bolts. That one is called a Hymax, and I wish we had more of those. But that's just what it looked like. And that one was one of our easier ones. But like I said, all in all, we have to deal with a lot of conditions out there to make these repairs and get the water turned back on for the residents as fast as possible.
Thank you all again so much for your interest. I love that you all are here. This makes me so happy. We have decades of experience up here. Obviously, again, you can tell how passionate we all are. It's not fake. It's very sincere. And again, I hope you leave here today with just maybe you had appreciation for us before, but maybe just a little bit more when you turn that faucet on and just realize truly how far that water has traveled to get to your house safely. So again, thank you all so much. In your bags, when you came in, I'd asked you to answer those questions. Hopefully, you have all the answers to those questions now. As you leave, you can leave those on the table. We'll come and get them. And then there's a feedback survey too. Just let us know how we did today. And then if you have any suggestions for future Lunch and Learns, because this is something that we definitely are gonna continue to do. So again, thank you so much for your time and your interest today. I truly appreciate it. We'll see you at the next one. Thank you.